Hi there and welcome. This is time for Physical Sciences. My name is Tinyiko Kosa TK, as you know me. And now today we're going to look at the lesson in Physical Sciences, and of course ranging from 10 to 12. And here at grade 10 level, we're going to look at composition, mass composition and the law of constant mass composition. And we'll move it on to look at acids and bases in grade 11, and finally looking at some chemical equilibrium at grade 12. So you stay with me and learn with me in this lesson, because it's going to be useful to you as a science student. Now, when we're looking at the law of constant composition, what do we mean? We are actually saying that if we have got a sample, okay, of a substance or of a particular compound, okay, any sample, another sample that will be somewhere, in other words, if I've got a sample here of a compound and a sample of a compound there, the way the composition of this substance is in terms of the atoms that are there, in terms of the moles that are there, should be the same here and should be the same there. In other words, if we say, for example, that in a particular sample I've got 99% hydrogen, 1% will be something else. If I have this sample, 99% will be hydrogen, 1% will be the other substance. I have another one of the same compound here, 99 will be hydrogen, the 1% will be coming from somewhere else. So that is the law of constant composition. So we can't have, if I have water molecule, which is an example we're going to have a look at here. If I say 88.8% is oxygen here in this water, say container of water half filled, 88.5% is oxygen. It means 11.5% will be hydrogen. I have a gallon full of water. Even in that gallon, I will have 88.5% oxygen and 11.5 hydrogen. That's just an example, and we're going to look at one that talks about water as well. Okay, so that's what it means. And elemental composition of samples, okay, samples of substances or compounds, they are given as percentages by mass, okay? Now, percentages by mass, from percentages by mass, there's other things that we can do there. We can be able to come up with the empirical formula of that substance. We can also be able to see from the empirical formula what would be actually the chemical formula for that particular substance. We can do that, okay? And we're going to have a look at one example that is going to help us do that quickly. Okay, now, if, like the example I've given, if I've got a sample of water, in any sample of water, I've got 88.81% oxygen, and I've got 11.19% hydrogen. So whether I have this small container here with that amount of water, okay, that amount of water, and I have a bigger one here with that amount of water, I've got 88.81% here, water, oxygen, and I've got 11.19% hydrogen there. The same thing here, I would be having oxygen 88.81% of that sample, and hydrogen, I would be having it as 11.19%. Okay, so that's how what the law says. Constant composition. In other words, it doesn't change. It doesn't matter how much of the sample you have, but that constant composition of elemental substances will be the same in all samples of the same compound. Quickly, let's have a look at the water sample again. And here we're going to look at how the ratio works out. Okay, now here you've got the ratio here for water, it's 88.81% oxygen. This is oxygen. and 11.19% hydrogen. Now, because this is by mass, I can actually say that this is 88.81 grams to 11.19 grams by mass. Therefore, from here, if I have that, I can work out the mole ratio. And how do I do that? Working out the mole ratio, I know that this one, 88.81 grams, is for oxygen. So oxygen, what is the molar mass of oxygen? It's 16. And what do I get there? Okay, so you use your calculator, 88.81, you divide that by 16, and what do you get? You will see you get 5.55. 5.55. And then on the other hand, you would have the hydrogen one. It's 11.19. Hydrogen molar mass is 1. So this will be 11.19. You take the smallest one and divide through to get the molar ratio. So 5.55 is the smaller one. So 5.55 there. What you will work out, this workout to will be 1:2. So you have 2 hydrogen atoms and oxygen, 1 oxygen atoms for water molecule. See you in the next section.